Hello, let me introduce myself as Karnya Sai. Today I am going to give the presentation of CAE2. The topic is unification in first order logic. Introduction to unification in first order logic. Unification is a process used to define if there is a substitution that makes different logical expression identical. It is fundamental in automated theorem, proving and logic programming such as in Prolog. The goal is to find the most different unifier that can unify a set of expressions with minimal assumptions. As shown in this figure, the first order and the is shown in the figure. The basic concepts of the first order logic. First order logic involves variable, constant functions, and predicates to express statement. As shown in the figure, the constants, for example, names like Sahara, these are the constants. Variables means that stores the value it will define, such as numbers like x and y. Predicates are the sisters or friends, for example. Functions are the by using this some keywords sqrt, average. Connector symbols are and or, these are the connectors. Equality that means is equals to. The quantifier means and or belongs to. The terms are the building blocks constructed from variables, constants, and functions. Formulas are constructed from predicates applied to the terms representing logical statements. What is unification? Unification is the process of finding substitutions for variables to make different expressions identical. A substitution replaces variables with terms, constants, or other variables. The unifier is a set of such substitutions that makes the expression synthetically equal. Types of unifiers. Most general unifiers MGU, that's called MGU, is a simplest substitution that unifies expression without adding unnecessary specifiers. Unifier is a set of substitutions that makes the expression identical, not necessarily the simplest. If no substitutions exist, the expressions are said to be non-uniformable. For a set of sentences that exist in most general uniform, this is a unique up to variable remaining. For example, s is equals to p of x comma y comma f of z, and s2 is equals to p of a comma w1 or, and then the most general unifier is u is equals to x by a comma y by w comma r by f of z. This is the MGU. For the resolution procedure, we want to find more general unifier of literators, a constant variables or functions, object of the link. The unification algorithm. The algorithm systematically compares terms and determines if they can be unified through substitution. It involves checking for conflicts such as different constants and resolving variables blinding. The process until continues until either a unifier is found or a contradiction is detected. Unified algorithms. By using this algorithm, we can perform this unification. These are the conditions for unifiability. Two expressions are unifiable if their corresponding words are either identical or can be made identical through substitutions. Variables can be freely substituted with the terms, but constants and functions must watch exactly. Occurs in check if used to prevent infinite regress by ensuring a variable does not appear within its own substitutions. The occurs of checks. The occurs check prevents assigning a variable to a term containing that variable. It avoids creating circular substitutions which can lead to non-terminating unification attempts. Although essential for correctness, it can be computationally expensive in some implementations. The application of this unification. Unification is a crucial in logic programming. Languages like Prolog for different matching and interference. It is used to automated theorem proving to simplify and resolve logical formulas. Unification also aids in type inference systems within programming languages for the formal verification. Limitations and challenges. Sorry, unification can be computationally intensive, especially with complex expressions and a large set of formulas. The occurs check add overhead, which can impact performance in practical systems. Some extensions like higher order unification are undecidable, posing theorem challenges. The summary and the conclusion of this unification of first order logic. Unification in first order logic is a core mechanism for matching and reasoning about logical expression. It relies on finding the most general unifiers to simplify and automate logical inference. Understanding unification enhances the development of logic-based systems and improving their reasoning capabilities. This is the summary and conclusion.